All right, what I have here is a data set for the Spinny Thing lab. All I've done is input the numbers over here. I've got the times going in the X column and the positions going in the Y column, and it looks like they're in centimeters. These times are in seconds. My graph's a little bit hard to see um, what's going on because it's really compacted. So if I look at this really horizontally, I don't go negative and I don't go greater than 20. So I'm going to go in here and change my x-axis labels. Let's make this be 25, and it doesn't really need to go less than like -5. Okay, so now when I look at it, is that a straight line? I can check by inserting an expression here, y equals mx plus b. Add sliders for those things. And then, let's see, it goes through at 0, 0. If I tip this up, boy, yeah, I don't know. That doesn't look like a straight line to me. Maybe if I adjust this a little bit. So a tell that you're not dealing with a straight line, but rather a curve, is that your dots at the beginning and end are on one side of your line, the dots in the middle on the other side of the line. So it's maybe not a line. So I'm going to get rid of let's get rid of these here. And maybe it's not y equals mx plus b. Maybe it's y equals ax squared. Try that. Adjust a here a little bit. Gosh, that's kind of hard to say. And let me turn in plus b. Let's see. That's like b. Is that really doing a lot for me? Not really. So I'm going to just stick with this for right now. Had I put in more data points, maybe this would have fit a little bit better. I'm just going to kind of chase it until it looks close. I can manually enter numbers here, 0.54. That's all right-ish. These points at the beginning aren't really following that, but 1, 2, 3, 4 towards the end. Ooh, there's a lot more data out there. Let's see. 8, 4, 5, 6, 7, 8. Boy, somewhere in there, I've kind of got something that follows those dots. Yeah, so y equals ax squared. So if I look at what's on y, I don't want to add another expression. I want to add a note. If I look at what's on there in terms of y, that would say position equals constant. That's what a represents, times time squared. Okay, times time raised to the second power. Plus b or whatever. So yeah, that's a quadratic relationship that I'm seeing here. Oftentimes, you'll be asked on the exam to graph variables in a linear form. That means we want to create a graph where this doesn't show up as a curve, where it shows up instead as a line. So if you look at this, you can kind of see how it's in the form y equals mx plus b. Positions the y. The constant there would be the slope. But x is not time, it's time squared. Okay? So what I need to do then is tell this thing to graph x1, but it needs to square it. Okay? And then it doesn't need to do anything to y1. So it can just plot the x1 versus y1. And let's see what that looks like. Ooh, it's really low to the ground there. Eek. Okay. So now it goes out a ways because I'm squaring all these values for time. It looks like my max y value needs to be somewhere around 250. But then the horizontal axis value, the vertical axis values, the y-axis values, they don't need to be quite so big. So let's go change these. They probably don't need to go above 100. Let's go 200, you say. Okay, and I really don't go very negative, so I'm going to make that be, let's make it be 0. All right, how's this look now? Is that a straight line? Maybe. I can kind of check that by going in here with the a equals mx plus b. Add some sliders for these things. Get rid of that. Me. Pretty close to what I had for a in that quadratic, right? Looks like that number is the same. Does it want b to be something? Maybe it does. I don't know. Okay. So I'm going to play around with that until I get something that looks like a decent fit. That looks all right, except for that last point. Okay. So maybe I want to go back and look at my data set. If you look at the data set, is it still speeding up at that point? You know, if you look at this, in this 2-second window here, it traveled about, what, 23 centimeters? And then in the last 2 seconds, it went 19. That doesn't seem like it's speeding up anymore. I might use that as the reason to want to get rid of that data point. Now, if I do that, oh, there we go. Fudge the data till it looks good. Okay. So now I'm feeling a little bit better about things. I'm going to exclude data. I only want data when it's speeding up. If it's clearly not speeding up, I'm going to clearly get rid of that data. So it looks like my slope on this linear form graph of position versus time squared, the slope is 0.5. What are the units on that? I'm going to put some thought into that. So anyways, go in and do the same thing to your graph of position versus time. Come up with a linear form and then find the slope of that linear form. Good luck.